Hello everyone. Today we are going to learn very important topic in agriculture, that is water requirement of the crops and how the different type of the soil that is going to influence the crop growth. So generally water is very essential for the germination, plant growth, nutrient transport and photosynthesis process. I think all of you are aware with that. So but different soils which is going to hold the water differently, and that is what we are going to will explore in this class. So next one, as you can see, India has a very great variety of soils. So this map it will show the different major soil types: alluvial soils, black, red, and yellow; laterite soils, arid soils, saline, and forest soils. Next we see that one soil texture triangle. So which is going to help us to classify the soils based on the proportion of the sand, silt, and clay. So sandy soils drains the water very quickly. The clay soils it will hold the water for a long time. The loam soils which are ideal for the agriculture. So this triangle generally will help us to identify exactly which soil type we have that one. So we'll start with the one by one. Let's begin with the alluvial soils, the most fertile soil in India. So it generally formed by the deposition of the rivers. It covers nearly 40% of the India. It is very rich in nutrients and best for the farming. So where it is get the occurring means the regions that we can see Indo-Gangetic plants and Rajasthan to West Bengal and East Coast. So here crops will be grown: wheat, maize, millets, sugarcane and pulses. So next one is black soil. It also called as a rigor or black cotton soil. So generally it is formed from the igneous rocks. It will hold the moisture for the longer period and it will be rich in magnesium and calcium also. It covers the completely 15% of the India. So Maharashtra, MP, Karnataka, Andhra Pradesh, it will cover the region. So crop here grown will be cotton, millets, pulses, and we can make some citrus fruits and also maize. So this soil will be cracked in the summer, but because it will become very sticky during the rains, making it ideal for the cotton cultivation mainly for the sticky nature. The next one, now we move to red and yellow soils. So it's generally formed from the metamorphic to and crystalline rocks. It will have the high iron content, so it will give the reddish color for that one. So it will be very poor in nitrogen and humus, so it needs a fertilizer for the high productivity. It will occur in the region of Karnataka, Madhya Pradesh, Odisha and Chhattisgarh. Here crops will be grown: wheat, tobacco, oil seeds and pulses. So it shows the different kind of the oil seeds here like groundnuts, soybean, sunflower, mustard and sesame. So these soils will support variety of oil seeds crops generally due to good drainage. The next is laterite soil, whose names come from the Latin word later. It means brick. So it is red due to completely high iron and aluminium. It will be deficient in organic matter. It will occupy around the 3.7% of India. It already occupies. So the region is Karnataka, Kerala, Tamil Nadu, Odisha, AP, Andhra Pradesh and Assam. So here crops will be grown mainly cashew nuts. So laterite soil generally suitable for the plantation crops, especially cashew, due to its drainage characteristics. The next one is the arid soil. It is also called as a desert soil. It's a sandy and low moisture. High salt content will be there and it will be very poor fertility when compared to other soils. And it will cover around 4.42% of India, mainly western Rajasthan, parts of the Haryana and Gujarat. So here we can crop bajra, jowar, millets, green grams and black grams. So these crops generally tolerate the drought and grow well in the lower water conditions also. So next finally we have the saline soils. It is also known as Uzra soils, infertile soils we'll call it as, because it is having the high salts, sodium, potassium, magnesium and poor vegetative growth. It will can be reclaimed as a using gypsum or lime. So it will occur around the region of Rann of Kutch, East Coast Delta, Sundarbans. So here crops will be grown: green grams, beans, these are very hardy, salt tolerant crops. Next is forest soil. This is also known as the mountain soil. These are generally mainly found at forest areas where the rainfall is very sufficient. And forest soils, it will vary from place to place. On the valley sides, because soil is very loamy and silty, while on the upper slopes it will become very coarse grained. So in the Himalayan region, the soil will be tends to be acidic. It will be very low in humus, but in the lower valleys it will become very fertile. So it will be found at Himalayas, Western Ghats and Eastern Ghats. Here crops will be grown like temperature fruits like apples, plums, pears and kiwis. So it is also suitable for the growing of tea, coffee and various spices like black peppers and ginger, turmeric, etc. So as you can see in the images. So these crops will generally thrive in the cooler climates only when compared to normal things. So here it mainly will grow up in hilly terrains. The next one is the peaty soil. So this soil will be rich in organic matter and humus. It is going to make very fertile soils when compared to all. So because of this high organic content, so peaty soils will be black and heavy in the nature. So this type of soil generally found with the heavy rainfall, high humidity. So such like coastal areas, Bengal, Odisha, Tamil Nadu. So major crops in peaty soils are jute, rice and rubber. So how tall jute plants can grow, how the rice grow in the waterlogging fields, how the rubber is trapped from the rubber trees, as you can imagine about the peaty soils here. So next we will discuss about the preparation of the land for the irrigation. So before planting any crop generally, land preparation is very important. So let's go through the step by step. The first one is the soil testing. The first step we'll call it as soil testing. So we test your soil pH, nutrients, fertility. So it will help us farmers to understand what nutrients are lacking and what fertilizers we have to use. So Indian government generally supports the farmer through schemes like soil health card scheme, so which provides the detailed information about the soil health. Second one is the leveling. So after the testing of the soil nutrients, the field has to be leveled. Leveling helps us to remove the completely uneven surfaces which is caused by the previous crops, and it will also prevent the waterlogging, so which can damage the crops and also avoid the soil erosion during the rain condition. Third one is the ploughing. So ploughing will be loosened and turns the top layer of the soil. So it will help us the nutrients rise to the surface and improving the air circulation. It also allows us to roots to grow deeper. So ploughing can be done using the different type of the ploughs also. The next one, harrowing. So this one is a secondary tillage practice, which means it happens after the main ploughing. So it breaks the soil clods into smaller pieces and prepares the soil for the leveling. Sometimes rotavators are used to break the soil even further. So next one is the seed bed preparation. Different crops will require the different type of the seed beds. So for example, potato needed few rows like about 50 to 60 centimeter apart. When you're taking for the sugar cane, it will follow the furrow irrigation size even larger when compared to potato. So finally, land preparation, it will require the various tractor implements like MB plough, cultivator, rotavator and land leveler, disc harrow, ridger. So these tools generally will help the farmers preparing the large areas of the land more efficiently. Next, we'll learn about the soil fertility, which is one of the most important factor for the successful crop production. So generally, it will have the several characteristics. So first, it contains a rich organic matter, so it is improve the soil health. Next, it will have the high cation exchange capacity (CEC), so it can hold and exchange the nutrients effectively. It has to maintain the optimum pH between the 6 to 7, and fertile soil generally has to get the drain well, and it will maintain the low salinity levels and nutrients, and it will also have the good structure. So generally soil fertility is vital for the plant growth and productivity, so it must be managed for the sustainable agriculture. This means farmers need to constantly monitor and improve the soil quality for a long-term farming. The next one is a soil water plant relationship, so we'll explore it. Plants need the soil and water has to grow. So the soil acts as an anchor that supports the plant and it will provide the medium for the root growth. So generally soil is made up of the three phases here. Those are the nothing but solid, liquid and gas. The solid phase, it is going to include the minerals like organic matter. Between the solids, they are the very tiny pores and those pores which are going to store the water and air. So this is a very important water inside the soil. It will help by the surface tension because of the soil particles. So that water, how much it can plant can absorb. So the too much water is present. The soil obviously it will pushes the air and roots can the suffocate. So but if the soil is very too dry, the water going to stick very tightly to the soil particles and the plants generally find it very hard to absorb. So this means that image is completely showing that how water moves between the soil and plant in the atmosphere. So continuous movement is essential for the plant survival completely. So next one, the soil water potential. So this is measure for the energy status of the water in the soil. So water always moves from an area of the higher potential to lower potential. In the soil, water potential values are generally negative. That means water is held with some kind of tension. So the completely sort of soil water might be around 0.3 bars. For the roots around 3 bars. So for the leaves around 15 bar and for air around 500 bars. So this means water move from less negative soil to more negative air. So plants create the tension between the pull to water from the soil into the roots and up to the stem and into the leaves. So one of the important part of the water potential here, this is the solute potential, which is influenced by the sugars and other dissolved substances which is inside the plant cells. So and also water it is going to travel soil from the roots to stems, stems to leaves, so leaves to completely air. So its potential must keep decreasing. So the movement has to be continued because water potential in the air is extremely low and the water naturally moves out through leaves during the transpiration process. So I think vertical distribution of the soil moisture we already discussed in the groundwater class. So I think I'll skip this one. You can check there. We'll continue the next topic. We'll move to soil moisture tension, some of the constants, moisture points. So this is the force with which water is held by the particles, soil particles. So low tension in the wet soils, that means plants can easily extract the water. High tension in the dry soils, so plants must work harder to take up the water. So soil moisture stress, so generally soil will dry, so tension is going to increase. These both are proportional to each other. So the plant struggles to absorb the water, which is going to lead the wilting point and reduce the growth and also low yields if stress is continuously going on. These are the standard soil moisture constants. The first one is the saturation. So all soil pores are filled with the water, no air is present here. The second one is the field capacity. This is the ideal condition. Excess water drains out will be there after the rainfall and the soil will hold the right amount of the water for the plant growth. And third one is the permanent wilting point. So this one, the soil becomes so dry, the plants can no longer extract the water, so they permanently wilt. So limiting soil moisture conditions, this will be determining how plants has to grow. Maximum limit, that means above field capacity, too much water will cause the waterlogging. Optimum range between the field capacity and wilting point, that means the best range for the crop growth. Minimum limit below the permanent wilting point, that means plant cannot recover never. So this image below the completely it will shows the from saturation to wilting point. It will helping us to visualize the each stage of the soil constants. Let's start with the next concept of the depth of irrigation. It refers the amount of water applied to the soil, that means moisture up to root zone, generally depending on the three factors. Root depth of the crop, that means shallow roots will be need less depth and deep roots will require more. Soil type, that means sandy soils need the light and frequent irrigation. Clay soils need the deeper and but less frequent irrigation. Third one is the moisture deficiency. So at the time of the irrigation completely, how the dry soil is at the time of watering, that is going to define that one. So example you can take for the shallow rooted crops like onion and cabbage, it will require the 3 to 5 centimeter depth. And for the medium rooted crops like wheat and groundnut, it requires the 6 to 10 centimeter depth. For the deep rooted crops like cotton and sugarcane, 10 to 15 centimeter or more than that. So always it will match the irrigation depth with the root zone depth. So now the frequency of the irrigation means how often irrigation is needed. It generally depends on the crop water requirement, etc., and soil's water holding capacity. Climatic conditions like hot and dry will get the more frequent, and for the cool and humid region it will less frequent. So generally the guidelines will define with the sandy soils frequent and light irrigation. For the clay soils less frequent and heavy irrigation. For the deep roots longer intervals is needed. So the different crops and soils demand the different irrigation schedules. So next some important terms in the irrigation planning. Grass command area GCA, total area that can be irrigated including the forest, villages, roads, everything under the canal can reach. So next one is a cultivable command area, only that area that was fit for the cultivation. So practically irrigatable area that we'll call it as a CCA. So next one is cultivable cultivated area, part of the CCA only. So that is currently under the cultivation. The fourth one, cultural uncultivated area. So it generally fit for the cultivation but not being used due to lack of water, maybe labor or fall for the soil recovery. So you can see some of the example pictures here. So remember this. This is going to be defined with the relation GCA is greater than CCA and it is greater than cultivable cultivated area. So that means these terms will help in evaluating the irrigation potential. So GCA refers the gross command area. It is greater than CCA cultivable command area. So it is greater than cultivable cultivated area. So next one, core depth, very important in the establishment of the stage of the crops here. So core depth defines with the minimum quantity of the water needed for the first irrigation. So example you can see here, for the rice it will require the 190 mm, wheat 135 mm, sugarcane 75 mm, cotton 135 mm. Core period means maximum time between the sowing and first irrigation. Example for the rice 2 to 3 weeks, for the wheat 3 weeks, and for the cotton 2 weeks. So if water is delayed beyond this period, crop growth badly will get affected. So next one, crop seasons. In India, crops are classified into the three major cropping seasons, Rabi, Kharif, Zaid. So sowing the time between the for the Rabi October to December, for the Kharif June to August, and for the Zaid it's March to May. Here harvesting means the months April to June, September to October, summer. The water source for the Rabi season is completely winter rainfall, and for the Kharif it's monsoon rains. For the Zaid you have to irrigate the soil. So examples of the Rabi means crops we can take it as a wheats, mustards. For the Kharif you can take the rice and maize. For the completely Zaid we can take the watermelon and cucumber. So crop selection generally depends on the rainfall and climatic conditions only. Crop rotations means it's a growing different crop families on the same land in a planned sequence, one by one, step by step. So here some of the principles is there. The first one, alternate deep rooted and shallow rooted groups and legum after non-legum to restore the nitrogen, and exhaustive crops followed by the less exhaustive crops. Crops of the different families to reduce the pest risk. And also we have the benefits here for the crop rotation. We can maintain the soil fertility. It will reduce the pests and diseases, and it will improve the soil structure. Better economic will get written and prevents the soil erosion. This is very sustainable farming practice now. So irrigation efficiencies. We aim to ensure the water generally used efficiently. There are the mainly four types. Conveyance efficiency. That means the field delivery where it's water released. Application efficiency. Water stored in the root zone where it's delivered. Storage efficiency. How well irrigation meets the water requirement. Water use efficiency. That means crop yield per unit of water. So that we can define higher efficiency equal to less wastage plus better productivity. So total water requirement, including we have to determine the required means. First one we will go with the concept to use, that means crop evapotranspiration. Second one, losses, that means seepage losses and evaporation losses. Leaching requirement, that means to wash the completely salts in the root zone. We can make the formula between the components. WR equal to IR plus ER plus S. WR means water requirement, IR means irrigation requirement, and here S means contribution from the soil profile. So generally, to identify the completely determination of the irrigation requirement, we have the some methods. First one is the soil moisture deficit method, and we can use the ETC method, concept to use method, and critical crop storage approach, and we can also use the IWCP irrigation method. These are all the methods, just they will identify that one how much irrigation requirement is needed. So this will help to schedule the irrigation scientifically. So assessment of irrigation water, generally changes can be collected between the two ways, like a area basis and volumetric basis. So area basis, it is a payment based on the area irrigated. The simple that we can encourages the waste, no motivation to save the water. The volumetric basis means payment based on the actual water delivered. It promotes the water use efficiency. So it will require the measuring devices and skilled operation also. So modern systems prefers the volumetric basis for the water conservations. Between the two states also they can prefer this one. The last one, concept to use of the water, factors affecting the concept to use. So it is completely going with the total quantity of the water which is used by the plants, by the transpiration and evaporation. So total concept to use is equal to evaporation plus transpiration, that we can make it the small terms. So here we have the different factors affecting the concept to use. Climatic factors like temperature, wind velocity, humidity, and sunshine. And the crop factors like a type of the crop, growth stage, and root depth. The soil factors, texture, moisture, and fertility condition. And agronomic practices like mulching, weeding, and use of the anti-transparents. So some of the methods generally we'll use to measure that one, direct measurement for the concept to use of the water in the fields. The first one is a lysimeter method, field experiment method, and pan evaporation method. These are the simple methods to most accurate. Some of the methods are costly also. They will estimate the completely concept to use of the water. So mainly we will use the equation of the Blaney-Criddle equation to estimate the evapotranspiration. That is nothing but ETC. That is completely we can call it as a concept to use. For that one units are per day. Here Kc means crop coefficient, and here P means daily mean percentage of annual daytime hours, and capital T means daily average temperature. So by using this formula you can find that how much consumptive use of water is getting affected by using the Blaney-Criddle equation. So I think up to now we covered so much of the irrigation and which is related to the water requirement of the crops also. We'll see in the next class.